we are going to use a spreadsheet to calculate a non-parametric analysis of the chi-square. Okay, so we've already watched the video looking at the M&Ms and the distribution of M&Ms in the package, and we're going to compare this to the M&Ms that the factory distribution says exist. So basically, this is what we expect to see in a bag, and what we actually observed might be something different. So let's take a look at that right now. So this is what we got by watching the video and what was actually in the bag. Raw number of 56 M&Ms. And then what was expected over here is the percentage. But remember, these are n's, these are percentages. They're not equivalent to one another. So what we're going to do is we're going to calculate what we actually expect to have. So if there are 56, we want 56 times 12.5%. That means 7. So there should have been 7 of these, 7 of these, 7 of these, 7 of these, and of course, double up for the 25%, but I'll just work that up for you. We have 56 times 0.25, we have 14. So that is what we expect in the ends, and this is what we actually observed in the end. So the question is this similar to this? Let's go back to the spreadsheet now. Okay, so we're back on the spreadsheet now, and we're going to put in the values. So we're going to use this formula to guide that experience for us. If you're good at putting formulas all in one shot, you are certainly welcome to do it that way. However, I'm going to do it into the individual pieces so you can see it broken down. So the expected, well, we did that on paper. We know that the orange and the blue are supposed to be 14%, or 14, not 14%, 14, and then yellow and green and brown and red are 7. Okay, that makes it add up to 56. Great. So we know they have the same. Where these are n's, not percentages. So we do observed minus expected equals observed minus expected. Great. I'm going to copy and paste that formula down. So we get all those values. Now we're going to do observe minus expected squares. There's a couple ways you could do that. I'm going to use the one that's represented here. We do the observe minus expected, and the caret gives the power of 2. Okay, and there we go. We got the 16. Copy those down. Great. Now we do observe minus expected squared. That's this one, right? The observe minus expected squared, that one, divided by the expected. So we do equals this one divided by the expected. Get that? And we'll copy and paste that down. Okay. So now what we've done is we've done the observed minus the expected squared divided by the expected, this section right here, for all of the individual values. And then at the end, you can see it says sum them up. Sigma means sum, add them all up. And I've already done that. So because I programmed the cells to do it, we get a value of 27.64. That is the chi-square value. Now we need to determine degrees of freedom, and degrees of freedom are basically each row minus 1. So we only have one row on this. We don't have a grid system. So we have a row, 1, 2, 3, 4, 5, 6, 6 minus 1. So we get 6 colors of M&Ms. 6 minus 1 is 5. That's our degrees of freedom. Now what we have to do is we have to figure out what the critical value is. So if we think about what a critical value is, the chi-square value has to be positive because we squared. So that's the 0 point. And then someplace along there will be some sort of critical value. Anything on this side of the critical value, not significantly different. Anything on this side of the critical value, significantly different. You look up the critical value in a table. Our chi-square value is 27.64. We have to figure out if it's on this side or on this side of the critical value. So we don't know where it falls. So in Blackboard, I've linked a critical values for chi-square, and it's based on degrees of freedom. We look at 0.05 as our alpha level of significance, And we look up degrees of freedom, 5, and we get a value of 11.071. So we've got a critical value of 11.071, and we know that our chi-square value is 27.64. So that's over here. 27.64. There's the chi-square. So that tells us that we've exceeded the critical value. So that means there is a statistically significant difference between the colors that we expect to have in the M&Ms and the ones that are actually in the bag that I bought. So since we know that this value is statistically significantly different because the critical value was 11.07, we know there's a statistically significant difference. Now the question becomes, where is it located? Very similar to like ANOVA, looking for that post hoc analysis to figure out where the difference actually lies. So to do that, we're going to do the standard residual formula, which is the observed minus expected divided by the square root of the expected. Okay, so that's a little more complicated, but what we can do is we do equals the observed minus the expected, we've already got that, divided by the SQRT of, so square root is that expected, close, enter. I'll just do this myself and copy it down. Standard residual calculations. So you might remember when the absolute value of the standard residual is greater than 2, then that is a major contributor to the chi-square. So in this case, blue is greater than 2. Absolute value of 2.9 is greater than 2. So that's a contributor. And then we have red. Red is a contributor too. So the ones that are statistically significantly different or off from what we expected to see are the blue and the red. Okay. And so if we go to write that up, I have a write-up of the chi-square already done for you, so you can take a look at what it looks like. So the research question, is there a significant difference in the number of colors of M&Ms when comparing to actual bag to the expected New Jersey factory distribution? So the null, as always, is the null. There's no statistically significant difference. And then the alternative is there is. We set our p-value at 0.05. We determine degrees of freedom and the critical value. We did that by looking that up in the table. We compute the test statistic. I did that on the spreadsheet, got that. So because the test statistic is greater than the critical value, we are going to reject the null, accept the alternative that there was a statistically significant difference, and then we conduct post hoc to determine where it is actually located, and we see that it is blue and red. The absolute value of the standard's residuals is greater than 2. So this is the guidance for calculating chi-square. Please use it in the analysis of nominal level data.